Guys, I'm sorry I'm not here today, but you're going to learn about the types of reactions anyway. There are 5 types of reactions. This is a super simple, easy tutorial about these. There's also the PowerPoint on Canvas and other videos that I've uploaded to your Canvas site if you need those. So this is just mine. So for types of reactions, we're going to start with the first type. The first type that we're going to discuss right now is the synthesis reaction. Synthesis is also sometimes called composition. I don't like composition, and we'll discuss that later, but according to the way the standards are written currently, your EOC is possibly going to use the word composition over the word synthesis. So I want you to be aware of that. In a synthesis reaction, we take two either compounds or elements and we combine them. So sometimes we'll also call this a combination reaction. And so they become one compound, AX. It's pretty simple. To identify a synthesis reaction, we always have one product. So that helps us identify a synthesis when we see one product. An example might be when hydrogen gas reacts with oxygen gas, it will form water. When I see this reaction, first of all, it's not balanced. I've got 2 oxygens here, so I need 2 here. That gives me 4 hydrogens, so putting a 2 out front gives me 4 hydrogens on both sides. Now that I have a balanced equation, it doesn't really affect the type, but it's just my pet peeve, so you always balance the equation. I see that there is one product that classifies this as a synthesis reaction. Sometimes you'll see these written with a compound. So you might see potassium chloride plus oxygen is going to make potassium chlorate. When I see this reaction, I've got 1K, 1Cl, but I've got 2 and 3 oxygens. So there's my 3-2 problem. So I need to put a 2 out front here and a 3 out front here. That then changes my potassium, so I need a 2 out front on this side. I have a nice balanced equation, but I still only see one product. Our second type of reaction is a decomposition. To decompose means to break apart, and so in a decomposition, we're going to take a compound and break it apart, either into other compounds that are simpler or into its elemental state. I can recognize a decomposition being the opposite of a composition. It has one reactant, and so that one reactant allows me to identify this type of reaction. If I have a compound such as aluminum chloride, that will break apart into aluminum and chlorine, but remember chlorine is diatomic. And so then I again have a 3-2 problem, so I need a 3 out front and a 2 here, so I need a 2 here. But I can identify this as a decomposition because I only have one reactant that's breaking apart. An example of a compound doing that would be carbonic acid. Carbonic acid is very unstable and it will always form carbon dioxide gas and water. Again, I've got 2 hydrogens, 1 carbon, but my oxygens are giving me, I've got 3 on this side, 2 on this side, but I can't forget that 1 went over here, and so this is already balanced. Again, it's a decomposition because I see one reactant. Our third type of reaction is a single replacement reaction, sometimes called a single displacement reaction. Replacement or displacement depends on just your feelings. In a single replacement, a similar element replaces a similar element from the compound. So in here, A and B are in the beginning of the alphabet and X is not. So B is going to replace A and take the compound or the anion, and then A will be by itself. In a single replacement, we don't have one reactant or one product, but we have someone who is alone on both sides, right? So these guys are single. If A and X were dating and X was like, dude, I'm done with you, I'm going to date B. So now B and X are together, and now A is alone, probably at home crying, or happy. Maybe it was a good thing. So there's always an element that is alone on both sides. So for example, if we have sodium chloride and fluorine gas, fluorine and chlorine are both halogens, so those are going to do a single replacement reaction. Remember that chlorine is diatomic, so it gets a 2 here, as well as fluorine. If I have 2 here, I need 2 on this side, and I need 2 on that side. I can identify this as a single replacement because fluorine is alone and chlorine is alone. Yes, they are diatomic, however, these are elemental states, and so we have the elements that are single on both sides. That identifies this as a single replacement reaction. Our fourth type of reaction is a double replacement or displacement reaction. In a double replacement, it's sort of like a do-si-do. Everyone sort of changes their cation and anion partner. I think it looks like a double rainbow. So the first cation will take the second anion, and the second cation will come and take the first anion. So you end up with AY plus BX. In a double replacement, you can always identify these because no one is alone. Everyone just switches partners. So an example of this might be calcium chloride plus lithium oxide. So in this reaction, calcium will come take oxygen. Those are even. And lithium will come and take chlorine. Plus 1 minus 1. Those are even. So to balance this, I need a 2 out front here. I can identify this as a double replacement because when I look at this equation, no one's alone. We have a compound, 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 and a compound. So without any elemental elements, I know this is a double replacement reaction. Our last type of reaction, I'm going to have to turn the page, is a combustion reaction. These are very fun because combustions go boom. However, the reason I don't like when they call a synthesis a composition is because composition and combustion, when you're reading and trying to take a test that is timed, can make you make a simple mistake. So please read carefully composition versus combustion. In a combustion reaction, we always have a hydrocarbon reacting with water, reacting with oxygen, I apologize, to form water and carbon dioxide. So definitely always water and always oxygen. Depending if we're burning nitrogen-containing compound, we might form ammonia instead. However, this is the main one that you're going to see in Honors Chem 1. So a hydrocarbon means a compound that contains hydrogen and carbon. Reacting with oxygen, remember, combustion or fire cannot exist without reacting with oxygen. We learned in Unit 2 that the word burn means to react with oxygen, and I don't want you to forget that now. We're always going to form water as our product. So for example, if I have methane, is very combustible. It will react with oxygen gas, and it will form carbon dioxide and water. If you want to write water first, it doesn't really matter to me. 3 plus 4 is the same as 4 plus 3, so the order of this doesn't matter. If I have 1 carbon, 4 hydrogens, so I need 4 hydrogens. That gives me 4 oxygens on this side, so I need a 2 out front to give me 4 oxygens on that side. Every time I see oxygen and water, I want to pick combustion. That's the easiest way to identify this type of reaction. It's a pretty easy one to identify because the products are always the same, but remember, these are the ones that are the hardest to balance. So there is your tutorial on the types of reactions. You should be able to do your PL. Have a good time.